All right, y'all, in this video, we are going to go through the unit circle start to finish so that we can hopefully get that down a little bit better and you can kind of see how this all works together, okay? All right, so first things first, we are going to just start. I'm going to start with degrees and work my way around the circle. We'll look at then radians, go around the circle, and then our coordinates. All right, so here at the beginning, we're at 0 degrees. Then we get to our special angle 30, 45, 60, and then we land up here at 90. So right there, that's just all of your degrees in that first quadrant. As we go, we're just going to keep adding. For these bigger gaps, you're going to add 30. For the little gaps, you're going to add 15, 15, 30. Okay? So from 90, we're going to get over here to 120. And we're going to add 15, 135, add 15, 150. And then add another 30, we get over here at 180. Okay, so you can see that we got halfway around, and that's 180 degrees. All right, let's continue our little degree journey. We're going to add 30 here, so this is 210. Add 15, so 225. Add 15, so 240. And we're going to add 30, we get down to 270. Add another 30, get to 300. Then add 15. Add 15, and then add 30, and we get to 360, just like that. So we made it all around the circle in our degrees. Let's look at radians. Remember, we start off here with 0 radians, and half of a revolution around the circle gets you to pi. So just remember how this gets broken into. This top section is 1 pi radians, which means halfway is pi over 2, half of pi. All right, then let's look at some of these other ones. If I looked at cutting the half in half, that's going to land us here at pi over 4. That's 1/4 of pi. Okay, so if I was looking at it here, this is 1/4 of pi. 2/4 is 1/2. This would be 3/4. Oh gosh, if I could write. Sorry, it's first thing in the morning and my coffee is not kicked in here. All right, so 3/4 of a pi. So 3 pi over 4. Look at these other little sections. Each one of these, we're looking at, this is a 1/6 of the way around the top. 1/6, 1/6, okay? So right here, this is pi over 6. Now this next one would be 2 pi over 6, but that reduces to pi over 3. Okay, this would be 3 pi over 6, which is 1/2. 4 pi over 6, but that reduces to 2 pi over 3. This would be 5 pi over 6. And then you get back to 6 pi over 6, which is 1 whole pi. All right, keep going around the circle. This next one would be 7 pi over 6. Okay, I'm going to keep going on that trend. I'll come back for the pi over 4s in a sec. But this was 7 pi over 6. This would be 8 pi over 6. And that reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. See, that was 9 pi over 6. 10 pi over 6 reduces to 5 pi over 3. 11 pi over 6. And then over here, we get 12 pi over 6 or just 2 pi. Okay? Remember the ones that cut in here in the middle of those? That's going to be your little pi over 4 scenario. So up at the top, we had 3 pi over 4. This would be 4 pi over 4. This guy's 5 pi over 4. All right, down here would have been 6 pi over 4. Reduces to 3/2. 7 pi over 4. Right there. All right, so degrees and radians, right? We can work through those pretty quickly. And once you get the hang of it, it goes real fast. Let's switch over to the coordinates for the rest of the video. Coordinates are trying to tell you exactly where do the points on the edge of the circle land. So the unit circle, if you remember, has a radius of 1, and it is centered at the origin. So this point in here if I had you label that, it would be the point 0, 0. Okay? And if the radius is 1, then from here to the edge is 1 unit. So this coordinate over here on the right, the x-coordinate is 1, the y-coordinate is 0. Let's go all the ones on the axes. If I went straight up, this guy right here, the x-coordinate would be 0, the y-coordinate is 1. Go over here to the left. To the left, your x-coordinate, -1, the y-coordinate, 0. And then straight down at the bottom, the x-coordinate is 0, the y-coordinate is -1. Okay, so right there we've got the ones on our axes. Then we can get these guys in here, but they come from special triangles. So let's talk about how we know what they're going to be. All right, I'm going to zoom in here on quadrant 1, and we're going to focus on special right triangles. So looking here at 30 degrees, I want you guys to remember that we've talked about the fact that in our unit circle, because the radius is 1, we're able to actually get our sine and cosine values to be giving us our y and our x values. I'm going to make a little note up here. I'm going to say y equals sine, and then x is equal to cosine. So just keep that in mind as we're going through all of this. Our points, you could be looking at your coordinate points as cosine for the x, sine for the y. So that's what I'm looking at with these values to get 30 degrees. For me to get that sine or the x and y, I'm going to do sine and cosine of that 30 degrees. So I'm going to pull up a couple things here. Number 1 are special right triangles. Okay, so here's your relationships with your 30, 60, 90s and your 45, 45, 90s. All right, we're focusing on the 30, 60 right now. So I'm going to cover up that 45 and let's look at that. All right, so for me to get the x coordinate at 30 degrees, we're going to do cosine of 30. Now cosine of 30, you're going to look at adjacent over hypotenuse, that's square root 3 over 2. For sine, or for y, you're going to do sine of 30. Sine of 30, opposite over hypotenuse, 1 over 2. So the coordinate points that I get here for this 30 degree is my x is that square root 3 over 2, while the y is 1/2. All right, since the number 60 comes from that same triangle, I'm going to go ahead and deal with that one, and then we'll deal with the 45s, okay? So for my 60 degree angle, we're going to do x is cosine of 60 degrees. Cosine of 60, we're looking from this angle. Adjacent is 1 over hypotenuse 2. And then looking here with sine of 60, opposite over hypotenuse, that's root 3 over 2. So what happens is my x and y coordinates just swap. And that's because we're coming from the opposite angle, the opposite and the adjacent switch. So cosine and sine switch. All right. Okay. Let's look at the 45-45 scenario, and then we should be able to get the rest of this real easy. So remember 45-45. If I want those coordinates, right, working with a 45-45-90 triangle, we're going to look at cosine of 45 for my x coordinate. So x is going to be cosine of 45 degrees. Okay, 45 adjacent over hypotenuse, that is 1 over root 2. I don't like square roots in the bottom, so I am going to rationalize, multiply top and bottom by square root of 2. We get square root of 2 over 2. And then for the y coordinate, we're going to do the same thing, but with sine. Sine opposite over hypotenuse is the same exact thing. So we still get root 2 over 2. Okay? So the rest of the circle comes from all these coordinates that we've already gotten. Now you can calculate them all over again if you want to find like cosine of 120 and sine of 120, and you'll get that. However, what's a little bit faster is once you have this first quadrant, then we can just like copy them because they're essentially the same thing. The only thing that's going to be different is that the signs may change. So over here in quadrant 2, you got to think about the fact that all of your x's are negative because it's on the left side. Other than that, the numbers are exactly the same as they are. It's a mirror image. So for these pi's over 3's, we're using these points, 1/2 and root 3 over 2. And so it's just that the x coordinate is going to be negative. Same thing over here with the pi over 4's. Pi over 4, I had root 2 over 2. Over here, it's going to be negative root 2 over 2, root 2 over 2. So it's just that the x value is negative. Or look at your pi over 6 values. Again, we're having a mirror image situation. So the only thing that's going to be different is the x's change to be negative. Otherwise, it is completely the same. Okay? We can do the exact same thing going mirror image top and bottom. Keep in mind here in this third quadrant that all of your values are negative, both your x and your y. So you got to keep that in mind with your signs. But then everything is just a mirror image. So at 5 pi over 6, this was root 3 over 2 and 1/2. Down here, 7 pi over 6, it's the same thing. Root 3 over 2 and 1/2. It's just that both of them are negative. All I'm going to do here is just continue to mirror what I have above. I know it doesn't fit on the screen very well, but a mirror image from the 3 pi over 4. With pi over 4s, you're just going to have root 2 over 2. In this quadrant, they're both negative. For the pi over 3's, again, I'm going to mimic the one that was above it, but it's going to have the 1/2, and then it will have the root 3 over 2. It's just that they're both negative. All right, we can reflect across the y again. Over here in quadrant 4, the only thing that should be negative is the y value. All the x's should stay positive. And then the values just reflect. So at the pi over 3's, we have 1/2 root 3 over 2. I have the exact same thing. It's just the y is negative. And the pi over 4's, this should be root 2 over 2 for both of them. Just the y is negative. And then last one over here, pi over 6's, we're going to have the root 3 over 2, 1/2, and we are done. So even me explaining through this, I've explained through it faster than what you're going to have time to do the test on in class. So you can definitely be able to work through it much quicker than that as long as you learn it. Usually me explaining stuff takes way longer than actually working it. So if I can explain it in this amount of time, you can work it in less. All right, y'all. Good luck, and I'll see you on the next one. Bye.